Hello, this is Mrs. Ross, and this is Lesson 33, the START problems. Let's go ahead and start with number 7. It says, find the area of a square whose vertices have coordinates, and then it gives us the coordinates. So let's go ahead and graph those. So 3, 6, so I come over 3, 1, 2, 3, up 6, 1, 2, 3, 4, 5. Oh, 6 is going to be about there. 3, 1, so 3, 1 is going to be here. Negative 2, 1, so I go negative 1, 2, 1, and then negative 2, 6 is going to be up here. So this is my square, and it wants to know the area. So we know that the area is equal to the side squared. So let's see. So if this goes here, and that's 6, so that's going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So each side is 5. So this is 5 squared, which is 5 times 5. Which is 25. Okay. Number 8 says round this number to the nearest hundredth. This means it's going to be a decimal. So let's see. This is tenths. This is hundredths. So this is what I'm going to be rounding. So this is what I'm going to be looking at. So that's 5. So it's going to be 15.74. That's my answer. Let me pick a different color here. Estimate the product. So this is an answer to a multiplication problem of 15.7 and 3.14 by rounding each to the nearest whole number. So this rounds to 16 and this rounds to 3. So 3 times 16 is... that I need a calculator for 48. Okay. And then number 9 says to use words to write each of these decimals. So I have 150, and that's my decimal point, 35. Let's see, this is tenths, hundredths, thousandths. Thousandths. Okay. And then for this one, I have tenths, hundredths, thousandths, 10 thousandths. So this is going to be 15 10 thousandths. Use digits to write each of these decimal numbers. Okay. Excuse me. 125 thousandths. So let's see. There's my decimal. This is tenths. This is hundredths. This is thousandths. So this is going to be 125. And then this is 100 and, that's my decimal point, 25 thousandths. So I know I have 100, my decimal point, and then I have tenths, hundredths, thousandths. So it says 25, so I'm going to put that there, put my 0 here. Number 11 says replace each circle with the proper comparison symbol. So I have 0.128 and 0.14, and as I look at these, this is the same, this is the same, this is larger. And then here I line up the decimals again. So I have, this is the same, this is the same, this is larger. A comparison symbol is greater than, less than, or equal to. Find the length of this segment in centimeters. So we have 4 centimeters, and then in millimeters. So I know that 10 millimeters equals 1 centimeter. So if I have 4 centimeters, I'm going to have 4 times 10 millimeters, or 40 millimeters. Okay. Okay. If we multiply one integer, so an integer is a positive, negative, or 0, by another integer, positive, negative, or 0, that is a whole number. Okay, so 0 just got kicked out. But not a counting number. Oh. Okay, so 0 is a whole number, but it's not a counting number. So really it's asking you anything times 0 is going to be 0. Why do they? Anyway, use prime factorization to find the least common denominator. So 27, 3 and 9, 3 and 3. So I have 27 is 3 times 3 times 3. And then 36, let me do 36 in a different color. 6 times 6, 2 times 3, 2 times 3. So I have 2 times 2 times 3. So I have this in common, and I have this in common. So let's see. I have 2 times 2, so that's that one and that one, times 3, that's that one, and then times 3 for this whole thing, and times 3 for this whole thing. So that gives me 4, 12, 36. 36 times 3 is 108. Okay, let's go ahead and do 18. We need a common denominator, and I'm going to choose 8 because both 4 and 2 go into 8. So let me bring this down. I'll write the original problem. And then I need to find common denominators. So to make this into a denominator of 8, I have to multiply by 2. 4 times 2 is 8. 3 times 2 is 6. This remains the same. And then to make this into a denominator of 8, I have to multiply by 4. 4 times 2 is 8. 4 times 1 is 4. Now I can add. So I have 6 plus 5 is 11. Plus 4 is 15 all over 8. Now I have to reduce. So 8 goes into 15 one time. And that is 1 7/8. Okay. Let's go ahead and do this. Don't worry about the blue square. Let's go ahead and do this one. I'm going to choose 12 as my common denominator. So I know that 4 times 3 is 12. So 3 times 3 is 9. And then here, I know 6 times 2 is 12. So 1 times 2 is 2. 9 minus 2 is 7/12, and that cannot be reduced. Let's try again. Nope. How about that? Let's do blue. All right, so on 20, I need a common denominator. I'm going to use 8. So let me go ahead and write this vertically. So this is going to come over because this isn't going to change. But this, I need to make a common denominator. So this is going to be 4, this is going to be 8, and this is going to be 4. Because 2 times 4 is 8, 4 times 1. So then 4 minus 3 is 1/8, and 4 minus nothing is, that's your answer to 20. Okay, again, we need a common denominator, and I'm going to choose 6 because 2 will go into 6. So let me rewrite this vertically. So this is going to just stay. And this I'm going to have to multiply the top and the bottom by 3. 2 times 3 is 6. 1 times 3 is 3. And then we have another problem. I can't take 5 away from 3, so I have to borrow 1. When I borrow 1, 1 comes in the form of 6 over 6. So I have 5, and then 3 plus 6 is 9 over 6. And this just comes over, nothing happens. 9 minus 5 is 4. 5 minus 2 is 3. And then we're going to reduce this by dividing by 2. So I have 3, and 4 divided by 2 is 2. 6 divided by 2 is 3. That's my answer. Okay. If one card is drawn from a regular deck of cards, so there's 52 total cards, what is the probability the card will not be an ace? So I know that there are 4 aces in a deck. So let's see, how many cards are there? I'm going to subtract. So if I have a total of 52, how many cards are not aces? 52 minus 4 is 48. So there's 48 cards that aren't an ace, and that's my probability. But my probability is an 8. It can be reduced. So let's just divide by 2. I'm not sure what the lowest common whatever. So this is going to be 24 over 52 divided by 2 is 26. Okay, I can divide again by 2. And I get 12 over 13. That's my answer. Okay. Consider the following division problem without dividing. Decide whether the quotient, the answer, will be greater than or less than 1. How did you decide? So 5 divided by 4 and 1, 6. So I know 4 goes into 5 at least once with some extra. So I'm going to say that it's greater than 1. When Paolo saw the following addition problem, he knew the sum would be greater than 13 and less than 15. How did he know? He probably rounded. So let's see. This is close to 9, and this is close to 6. So that's where I got the 15. And then if I did 8 plus 5, which is not the correct way to round, I'd get 13. So that's how he knew. And I think that's the end of the start problems for lesson 33. Please let me know if you have any questions.